Hello, I hope you're having a good day. This is Stephen Garrard. I'm talking about conducting educational research, and I want to raise an important topic, which is how do we judge the quality of research, our own or other people's? This is important because if you were doing, say, a review of evidence, existing stuff from the literature, it's been demonstrated repeatedly that if you assemble this without consideration of the quality of the underlying research, then you can come up with misleading results. And then that could influence, policymakers, practitioners, families, whatever, who are misled by the evidence or the so-called evidence from the review into doing something which might not be effective. It would be a waste of a chance, or it could even be harmful. This is unethical. So it's absolutely crucial that when you assemble an evidence base, when you do a structured review or something similar, you do judge the quality of the evidence. Because if you don't do that, what happens is that the low quality studies will be given the same weight as the high quality studies, and so will distort the results because they might have different pictures. But even more dramatically, it's been demonstrated that the weak research tends to have more extreme results. So, for example, if you're looking at effect size, weak research tends to have bigger effect sizes than high quality research. So if you simply aggregate or average the results in your synthesis, you'll end up with bigger effect sizes than you should, because it becomes obvious if you look at the quality that where people have made a serious attempt to robustly evaluate something, the effect sizes are smaller. They may still be positive. You might still conclude that, whatever, that your approach has promise or the topic is interesting, but your results would be safer. So judging the quality of research matters. There have been several approaches to doing this, and many of them came originally from health and medicine, as you might expect. And they all have very similar features and similar ideas underlying them, as you would expect. But until recently, they've all had various problems. And the two most common problems are there in the original one that I found, the Maryland scale for judging the quality of research. And in the Maryland scale, it assumes that the study is a randomized controlled trial, so it's an experimental design. And if it's not, if it's a longitudinal design or a cross-sectional design, then it's downgraded automatically. This is because that's what the Maryland scale was set up for, and a lot of subsequent studies, scales, have been designed to come up to address different kinds of research. Now, the problem with that is it means you can't ever combine successfully the quality ratings for different kinds of research. You can't compare a longitudinal study with a randomized controlled trial fairly because you're using a different scale for it. The most extreme one is where people have this fake division between quantitative and qualitative designs or qualitative research, and then they have different words and different types for that. You cannot then synthesize evidence properly. So what we're looking for is a way of judging research in a generic way, using features that all of them would have in order to be able to draw comparisons. Not assuming any kind of hierarchy. So, for example, a longitudinal study would be weaker, maybe considerably weaker, than a randomized controlled trial for asking a causal question. Does this approach to teaching work? But a longitudinal study would make much more sense if you're looking at changes over time. And if you're looking at changes over time and you're not interested in causal things, then a randomized controlled trial might be a ridiculous thing to use. So the design depends on your research question. That's the crucial thing. And once you've got the research question, then you can begin to judge how good the evidence is in addressing that question. So the model I'm going to propose for you is generic, and it's without sort of prejudgment of a hierarchy of better or worse research. And we're looking for factors or issues that would be generic to all kinds of research. But in order to judge, the research report needs to be full and it needs to be clear. So you have to be able to understand it, so you can then look for the characteristics of the research that you want to know about. But Unfortunately, in education research, that doesn't happen very often. Many reports, you look at them and you think, this is not somebody genuinely trying to explain something to me. This is somebody playing games with words, trying to sound clever. You have neologisms, long paragraphs, long sentences, just made up stuff. And you just wonder what is going on here. I think people are either trying to hide the fact that they don't know anything, or they haven't done anything, or that what they've done is obvious or wrong. But if you're reading something and you genuinely can't understand it, and it's in your area, and you don't think the author's told you what you need to know in order to be able to judge it, then you judge it low. You say this is poor quality research. You have to be of a sufficient standard for you to be able to read it so that you can make a judgment. It doesn't have to be high quality literature, but it has to be as plain and clear. The standard of research reporting needs to improve dramatically, I think, in education research. And I think funders and editors and so on have a responsibility there to basically just reject anything which is written in this pompous academic-y style. But for the purposes of judging quality, just downgrade anything like that. If you can't tell, there used to be this thing where about 20, 30 years ago, there was a general criticism of education research that people didn't report the number of cases in their studies. I think that's improved now, and I think we do generally know how many cases there are. It's not always terribly clear, but it is reported. But there are still many things that are left out of reports that should be there. And let's talk about some of them. So I call this approach a sieve, basically because each piece of research that you evaluate individually drops down to the lowest level. It's more like panning for gold. You're looking for those nuggets of research which will be useful to you, which are safe enough for you to use in your reviews without prejudice. It's important to remember that when we look at any factor, we're saying that all other factors will remain equal. So, for example, if we looked at a study, or two studies, both of which had exactly the same characteristics and be done in exactly the same way, but one had 10 cases, 10 students in it, and one had 1,000 students in it, then obviously the second example is better research, isn't it? Because it's bigger. It's not that, oh, it's bigger, therefore it's got shallower data or it's got more missing data, because we're saying everything, we'll assume that everything else remains the same. If everything else remains the same, then a bigger study is better than a smaller study. There's a kind of resistance to that idea from some people, but if you think about it logically, it must be the case that bigger is better. And you'd use the sieve approach where you score each issue from 0 to 4 padlocks, 4 being the best you could expect in the real life research, and 0 meaning this research is basically of no use to anybody. And you judge. So first of all, let's take the issue of scale. How big do you want your study to be taken seriously? We all know that if you were judging whether boys do better than girls at school, and you had one boy and one girl in the study, then the study is a waste of time. And if you had 1 million boys and 1 million girls, and the same study, the same quality, then it would be taken very seriously because it's large. Somewhere between 1 and 1 million is, the point at which you'd say, I will or will not accept this as trustworthy evidence. For me, it would be several hundred. I'm looking for several hundred cases. Remember, it's not several hundred altogether. It's several hundred in each group, for boys and girls or whatever it is you're comparing. So we're looking at the size of the smallest group that you're going to use in any comparison in your research. And that, for me, that has to then be in hundreds of cases. I mean, sometimes it can't be, but then you have to be appropriately humble about the things you can claim and do about it. Now, you may have a slightly higher expectation or a slightly lower expectation. You might think that 60 cases is enough in one group. Well, I'm not here to argue about that. You've got to be able to defend what you decide. How many are you happy with? Again, remember, it doesn't depend on the methods you've used to collect the data. If you're going to make a claim that there's a difference or a trend or a pattern, then how safely you can say that depends on partly the number of cases in it, regardless of how you collect the data, and if you want people to take notice of it. There's also the quality of the data. So it's not just how many cases, but when you collect the data, how good is it? Now, obviously, that can be under your control. You can do it sloppily. You can use silly measurements or scales or whatever. You could do incompetent interviews. But mostly, this is something which is beyond our control. You know, we don't choose to research things on the basis of how good the data on that thing is. In fact, we might often choose to research things which are where we have less secure data. I'll tell you what I mean. We could go into a school and we could count how many children there are in each classroom. And that would be a fairly safe number. We could check it, we could get more people to do it, and so on. So a count is a fairly good quality measure. We could measure how well the children do in a maths test, a standardized maths test that's been validated elsewhere. And that would be a less good measure than the count of the number of people in the room. Just intrinsically, it's a worse measure, but it would be careful and so on, and it would still be good. It would be better than, for example, asking children how much they enjoyed maths. That measure would be much weaker, right? This doesn't make it less important. It just means it's, or less interesting. It's just less secure for us. So if you're judging how good is a measure, you know, between a count, say, or you know, a good test or something, or a measurement of something, a direct measurement, which you can calibrate and verify, or something which is what's called a latent variable, something you can't see or touch or smell or kick. So when you're rating studies, often you might find studies that have 2 or more outcomes. So, for example, there might be a randomized controlled trial about improving maths, and the outcomes are a test of maths knowledge and a survey of attitudes to maths and its enjoyment. And both are perfectly good outcomes for the randomized controlled trial. But if the maths test is a standardized test, it'll probably be a higher quality than the data from the attitudes. That's just a fact of life. The attitude results might be more interesting, but they're more likely to have problems with them. So you've got to judge the quality of the data, which is not under your control. Third aspect then is missing data. Whenever you start doing research, then you start having things like non-response, people won't take part, or people will drop out from research, or they will refuse to answer or won't be able to answer certain questions, or won't be able to comment on certain issues you raised in an interview, whatever it is. And as soon as that happens, you've got bias creeping in. These are not random events. People don't decide not to respond to your survey randomly. They could be away, they could be ill, they could be have low levels of literacy, they might be terribly busy and so on. And these things then bias the responses. And if you take the responses you do get and treat them as being somehow a random subset of all the cases that you could have had, then you will be misleading your reader. So you need to record and report missing data, and I've talked about this in another video. But for the purposes of judging the quality of research, the amount of missing data is fundamental to whether we think this thing is trustworthy. So this is an area which is very badly reported still. So if they don't tell you about missing data, then probably there is a lot of missing data and you'll have to downgrade the report in terms of its quality. How much is missing data is okay? It's really hard to say. And we see 0 is good, 10% might be acceptable, 30% is getting very dangerous, 50%, 60% is, you know, you basically, the research is destroyed by having that much missing data. And it's not just how much missing data, it's how much missing data in each group for a comparison. So in our example of a maths experiment to teach maths differently or something, if there are more people who drop out of the group that was supposed to be taught maths in a new way, if they were the least mathematical ability or the least opinionated or the least confident, that might make it look as though the group that had the new maths approach had done better than the other group. But it would just be false. It would be bias caused by dropout. So that's the third one. And the fourth one, I suppose, is the design itself. How well does the design that's been used fit the research questions? You'd think it would be obvious, and yet most studies don't have a design, as a reported design, and most of them, if you work out what the design is, design does not fit the questions. So if you're making a comparison, you need comparison groups. If you're looking at changes over time, you need to have data from more than one period of time. These are the obvious things. If you're asking a causal question, you need something like a randomized control trial or regression discontinuity. This should be obvious, but it isn't. And there are papers out there all over the place drawing distinction between groups that don't exist, or making claims of changes over time where there's only data from one time. There are other things we could consider relevant to the validity of a study. So this is what's called the internal validity of a study, which is how much we trust the results, how much we'd be willing to wager that they were true or not. But most of these other factors are minor in comparison and not as important. One thing that people worry about is called generality or generalizability. That is, to what extent are the results true of a wider group of people who were not involved in the study? But I hope you can see, if you think about it, that this doesn't matter unless the results are trustworthy. There's no point at all in asking whether some shoddy results from a weak piece of research would also be true of some other setting or some other context. We're only concerned with whether the results would be more widely and more generally applicable if we actually trust the research that's been done with the cases it's done with. So judging the trustworthiness of research is a primary function, whether you're doing a review or you're thinking about generality. And I think these four elements, the scale, the quality of the data involved, how much data or cases are missing, and whether the design or how well the design fits the research question. And in the sieve, which is explained with the table and so on in the book, the studies would drop down to the lowest level on each of those four elements. And then you'd read across to have a score from 0 to 4. Again, I say where 4 is about the best you can imagine. And then what you do is you take that's your gold. This is the stuff that you've been searching for that's going to tell you the answer to your research question so far. And you'll give much less weight to the stuff which is lower rated. And then you avoid the bias I talked about at the beginning, where the low rated studies will appear to have much more exciting results, and you won't be misled by that. So good luck with it.